So in today's video, we're going to go ahead and briefly cover integrating exponential functions. And so suppose we're taking the indefinite integral of a to the x times the natural log of a dx, where a is just going to be some arbitrary positive real number. Then we know that this is going to be equal to a to the x plus c. And this just directly comes from the fact that the derivative with respect to x of an exponential function a to the x is just equal to a to the x times the natural log of a. And of course, again, a is a positive real number. And we actually know that when we do take the natural log of a, and again, like I said, I have to keep reiterating this, a is a positive real number, then we know that the natural log of a is just going to be some other real number. This is just going to be a member of R. And so hence, this is just going to be a constant. It's like a scalar, like any other number. It may not be as, pleasant as other numbers, as some simple integers, but the natural log of a is itself a real number. It's just a constant. And so now with that in mind, let's go ahead and do a couple of different examples over here. So first of all, we're taking the indefinite integral of 7 times the natural log of 2 times 2 to the x. So here we have the 2 to the x, we have natural log of 2, and then we have the 7 over here as a scalar. And so we can just go ahead and simply recognize the formula, and we can tell that this is going to be equal to 7 times 2 to the x plus c. We add the constant of integration, and this right over here, this 7 times 2 to the x just comes from recognizing this form, natural log of 2 times 2 to the x with the 7 as a scalar. And then next up here we have the indefinite integral of the natural log of 3 cubed, so the natural log of 3, all of that raised to the third power, times 3 to the x dx. So here we have the 3 to the x, here we have the natural log of 3 cubed, and what we need to do is we just need to manipulate this a little bit, right? So we can rewrite this as the indefinite integral of the natural log of 3 squared times the natural log of 3 times 3 to the x dx, right? And so now we have the natural log of 3, we have the 3 to the x, and this natural log of 3 cubed right over here, or natural log of 3 squared rather, is just going to be some constant, right? It doesn't really matter what that constant is, we just know it's going to be some arbitrary scaling factor. And so we can just go ahead and write this as the natural log of 3 squared times 3 to the x plus c. And that would be our final answer right over there. And if you take the derivative of this, you will in fact end up with the natural log of 3 cubed times 3 to the x. And then next up over here, we have the indefinite integral of the natural log of 2 to the fourth power times 8 to the x minus 2 over 3. And so the way that I would approach this looks a little bit complicated at first, but we just have to rewrite a little bit. So first of all, we have the natural log of 2 to the fourth. We can write that as the natural log of 2 cubed times the natural log of 2 if we would like. And then over here, this 8 to the x minus 2 over 3, we want to get this in the form such that the base of this exponent is actually equal to 2. And so we know that 8 is just 2 to the third power, so this is 2 to the third, and we're raising that to the x minus 2 over 3, and then we have the dx over here. Well, we know that this 1 over 3 and this 3 are going to cancel out, and so we end up with this simply being equal to the integral of the natural log of 2 cubed times the natural log of 2 times this is going to be 2 to the x minus 2 dx. And now just a little bit more manipulation, we can write this as the integral of the natural log of 2 cubed times the natural log of 2. And then over here, 2 to the x minus 2, we can write that as 2 to the x times 2 to the negative 2, but that's just going to be equal to 1 over 4, right, dx. And so this 1 over 4 over here, this natural log of 2 to the third, those are just going to be some scaling factors. Here we have the natural log of 2 times 2 to the x, and so right over here, this final answer is going to be equal to 1/4 natural log of 2 to the third power times 2 to the x plus c. And that's our final answer. So it looked a little bit complicated, but it just requires a little bit of rewriting before integrating. And then finally over here we have the definite integral from 1 to 3 of 4 to the x dx. So we have the 4 to the x, but we don't have the natural log of 4, but that's fine. All we have to do is just manipulate a little bit. We know that the natural log of 4 is just some real constant. It's a scalar, right? And so we can rewrite this as the definite integral from 1 to 3 of, what we can do is we can multiply by the natural log of 4. So natural log of 4 times 4 to the x dx. But then since we're multiplying by a constant, we also have to divide by that constant. So 1 over the natural log of 4. And if we bring this natural log of 4 in, or the 1 over natural log of 4, then these will cancel out. And so we didn't really change the value over here. And then we can continue with this. We get 1 over the natural log of 4 times 4 to the x, right, because we now have 4 to the x ln of 4, and we're evaluating that from 3 to 1. So that's 1 over ln of 4 times 4 cubed is just 64, minus 4 to the first, which is just 4, and hence our final answer is 60 over the natural log of 4. And so I hope that this is not too confusing. It really just requires you to just manipulate these integrals in order to get it into a more recognizable form.